As you can see, I'm watching Ellen in here while I do daycare.
Hi.
And we've got Jake eating a sandwich. Here's a question posed to you by Jake.
Alright, let's put my
Maybe
sandwich.
you can help me. Because as you've seen, I watch Ellen.
Alright, so I was going through one of Einstein's equations, you know, the one that says mass equals rest mass divided by square root 1 minus v squared by c squared. Eventually, I did manage to get out of that F equals m dv/t, which is the definition of the force, but the thing that kind of concerned me was, how come you can accelerate, light travels at a constant speed, but as in, it doesn't accelerate forward or backward, but it does accelerate exactly sideways in certain cases.
And then continue on with what you were telling me and what you think and the different things, what you came up with.
Personally, I'm believing that there would be a different universal speed limit that isn't the speed of light, but probably slightly larger than it, maybe 0.9 times larger. Haven't quite worked it out yet, but to the point where it's actually related to the density of the universe. And then that would mean tachyons exist when light has mass. And then every time you would see a c squared, you'd replace it with some larger c, except for in the case of E equals mc squared. Is it still on?
Yeah. As you can see, I'm really going to need you guys' help with this. Thanks.
Alright, so today we're going to talk about time-independent quantum mechanics and some effects of the Schrodinger equation. So first we're going to talk about one of the effects of the Schrodinger equation, which is E sub n equals negative r sub h over n squared, where E sub n is going to be the energy of the principal quantum number, which equals negative r sub h, which is going to be the Rydberg constant over n squared, the principal quantum number squared. So now we're going to talk about time-independent quantum mechanics, which is what I said earlier, where psi, which looks like that, is going to be a function of r, theta, and phi. I wrote my phi wrong. Phi. Not good enough. When originally, psi would be a function of r, theta, phi, and time. So time-independent quantum mechanics. This is going to create two more quantum numbers, just like n. Now, don't forget that n can be greater than or equal to 1, and it can go all the way up to infinity. It's just an integer, greater than 0. So now, because of this, the two quantum numbers that we're going to have is L, which is going to be the angular momentum quantum number, I don't know if I abbreviated quantum right, but, and M, which is going to be the magnetic quantum number. And L is going to be greater than or equal to 0, and it's going to be an integer, and it's going to be less than or equal to n minus 1. The reason for this is because if L were n, and don't forget L is an integer, that would make, n is the sum of both the potential energy and the kinetic energy. And if L was n, then that would make n only the kinetic energy, which is a no-no. I just like saying that. And then, so M is going to be tied to L, which means it's going to be greater than or equal to negative L, and it's going to be less than or equal to L, except it's tied to L.